We are doing chapter biomolecules, and today we'll be doing NCERT exercise question 10.6 to 10.10. First question is, what is glycogen and how it is different from starch? So glycogen is a polysaccharide, and it is made up of a large number of alpha D glucose units. So when alpha D glucose units connect together by glycosidic linkage, they form glycogen polysaccharide, and glycogen is a branched polymer. Okay, there are large number of branches in case of glycogen. Now second part, that how it is different from starch. So if we look in detail, glycogen is the branched polymer of alpha D glucose, and this is alpha D glucose. And starch is not a single compound. It is made up of two compounds, amylose and amylopectin. And out of this, your amylose is a linear polymer of alpha D glucose, while amylopectin is a branch polymer of alpha D glucose. But in both the cases, your monomer is alpha D glucose, as we have in case of glycogen. But how they are different? Your glycogen is highly branched, while amylopectin is not highly branched. We are having less number of branches in case of amylopectin of starch. Now second point of difference is that glycogen consists of 10 to 14 glucose unit, while your amylopectin consists of 20 to 25 glucose units. And if we look into where these polysaccharides are present, so glycogen is a storage form of glucose in animals and humans, while your starch is storage form of glucose in plants. Okay, so starch is found in plants while glycogen is found in animals and humans. So this is all about the difference between glycogen and starch. Come to the next question. What are a hydrolysis product of sucrose and second lactose? So sucrose and lactose both are disaccharide, means they are made up of two sugar molecule, or two sugar molecules are connected to each other to give sucrose or lactose. But how they are different, or how we can break them? First point, hydrolysis means we are breaking down these molecules in the presence of water. So have a look here in case of sucrose. Sucrose on hydrolysis gives one molecule each of glucose and fructose. So this is glucose and fructose. Molecular formula is same for glucose and fructose, but their structures are different. How? Your glucose is basically your aldohexose, while fructose is your ketohexose. Okay, and this hydrolysis will take place either in the presence of your H plus ion or hydronium ion, or in the presence of enzyme invertase. Okay, so this is how we are getting glucose and fructose after the hydrolysis of sucrose. Now second part, lactose. Lactose on hydrolysis gives one molecule of glucose and galactose. Okay, glucose and galactose, these two again have the same molecular formula, and their structures are also same. Only the difference is of stereochemistry. Okay, they have different orientation of OH group. Therefore, they are different from each other. Okay, so lactose on hydrolysis will give you glucose and galactose. And this too takes place in acidic medium or in the presence of enzyme called as lactase. Okay, so this is all about hydrolysis of these two disaccharides. Now come to the third question. What is basic structure difference between starch and cellulose? We have done difference between glycogen and your cellulose. Now we will be discussing what is the difference between starch and cellulose. As we discuss, your starch is made up of two compounds, amylose and amylopectin. Okay, there are two compounds, amylose and amylopectin, while your cellulose is a single compound. Now, next major difference is that in the starch is a polymer of alpha D-glucose, while your cellulose is a polymer of beta D-glucose. Okay, what is alpha D-glucose? In case of alpha D-glucose, on the first carbon we have OH group below the ring of your molecule, while in case of beta D-glucose, this is your beta carbon. So here OH group is above the plane of your molecule. Okay, so if OH on first carbon is below the ring, it is alpha D-glucose, and it is above the ring, it is beta D-glucose. Next difference, in case of amylose, first carbon of your 1-glucose is connected to fourth carbon of other through alpha glycosidic linkage. Alpha glycosidic linkage is present in case of your the first one, that is starch. While if we look into the other one, that is cellulose, in this case we have beta glycosidic linkage between first carbon of one molecule and fourth carbon of the second molecule. So how these first and fourth carbon are having two different type of linkage, one alpha link, another one is beta link. So we will understand this by the structure of amylose. Here we have shown structure of amylose in case of starch. So this is the alpha link, while in case of cellulose, this is your beta link. So how we are having two different type of link. Okay, now if we look in detail, come back to glucose molecule, alpha D-glucose, which is in case of your starch. Your first carbon is having OH below the ring, and fourth carbon is also having OH below the ring. That means your first carbon as well as fourth carbon both have same stereochemistry. So when they form glycosidic bond, this is the glycosidic linkage. This is how the linear molecule is formed. While in case of your beta link, which we get from beta D-glucose, so first carbon in case of beta D-glucose is having OH above the ring, while fourth carbon is having the below the ring. So the orientation which is possible for the polymer formation is this one, and therefore when two different carbon are having different stereochemistry, we will be getting this beta link. That is, one is above, another one is below. So in case of alpha link, the two carbon which are involved, they have same stereochemistry, while in case of beta link, the two carbon which are involved, they have different stereochemistry or 3D orientation of OH group. So this is all about the difference between starch and cellulose. I hope it is clear to you. Next question is, what happens when D-glucose is treated with following reagent? First reagent is hydrogen iodide, second one is bromine water, and third one is nitric acid, HNO3. So here we have given the ring structure, that is your hemiacetal form of your glucose, that we call as glucopyranose. Okay, and in this ring structure, this ring structure is always in equilibrium with the open chain form of glucose. So this is open chain structure of glucose. Okay, so whenever we are treating with a reagent, either of them will react with the reagent to give a particular product. So when we are treating first with hydrogen iodide, your glucose undergo reduction and we get N-hexane. Okay, and this is what indicative of presence of a straight chain molecule, that is N-hexane is produced after treating with hydrogen iodide, and in this case your CHO group as well as the OH group, all OH group, they are undergoing reduction. So with hydrogen iodide, reduction takes place and we are getting alkane, which is N-hexane, because we have 6 carbon atom in the glucose molecule. Second one, when we treat with bromine water, okay, that is your solution or a mixture of bromine and water, and in this case oxidation takes place. And what happens, your CHO group, this group will undergo oxidation, and we will be getting a carboxylic acid group on this particular carbon in place of CHO group, and the compound is called as gluconic acid. This is oxidation of what? It is oxidation of what? Only the aldehyde group. Oxidation of aldehyde group. Okay. While in the third case, if we look, when we treat with nitric acid, in this case we have oxidation of OH and CHO both. So have a look here. On the first carbon, CHO is oxidized to carboxylic acid group, while on the last carbon your OH present is oxidized again to carboxylic acid group, and the compound which we get here is saccharic acid. Okay, so we can summarize, when we treat with hydrogen iodide, your glucose molecule undergo reduction to give you alkane, that is N-hexane. When we treat with bromine water, your aldehyde group undergo oxidation to give you gluconic acid, while when we treat with stronger agent or oxidizing agent, that is nitric acid, in this case both your OH as well as CHO group, that is this is CHO and this OH on the last carbon, they undergo oxidation to give you your saccharic acid, where we have 2 carboxylic acid group on the terminal carbon. So this is all about this question. Now come to the next one. We have to give those reactions of D-glucose which cannot be explained by its open chain structure. So few reactions of D-glucose we cannot explain with the help of open chain structure. So what are these reactions? Okay, the first reaction, your glucose never give Schiff's test although it is having CHO group. Why? Because CHO group is blocked in case of a ring structure, therefore it will not react with Schiff's reagent. So it is a proof that it is not having free CHO group. Why? It is involved in the ring formation. Second one, it does not form a hydrosulfide addition product with your sodium hydrogen sulfide or sodium bisulfide. Okay, which we are expecting because of the presence of again CHO group in case of glucose. So the next point is the pentacetate of glucose does not react with hydroxylamine. Okay, and it is a reflection of absence of free CHO. What is the meaning of this? So have a look on this your open chain structure. It is having how many OH? 5 OH. Same we have in the ring structure also, 1 2 3 4 5 OH. Now if we block all these OH by converting them to acetate or by oxidizing them to acetate group, so we will be left with only this CHO which will interact with your hydroxylamine. Okay, but what we found, glucose, in case of glucose, even with hydroxylamine we are not getting any reaction. Why? Because the terminal CHO is involved in the ring formation in the ring structure, therefore it will not react with hydroxylamine. So it is again a proof that it is having the ring structure. Next one, the fourth one, your glucose exists in 2 forms, alpha form and beta form, and these 2 forms are basically 2 different types of crystals of glucose. Okay, so at a temperature 303 Kelvin, if we crystallize glucose from its concentrated solution, we will be getting your alpha form, which is having melting point 419 Kelvin, while if we crystallize at a higher temperature, that is your 371 Kelvin, from hot saturated solution of glucose, we will be getting the beta form, which is having melting point slightly higher as 423 Kelvin. So why we are getting two form, alpha and beta form? It is not explainable with the help of your straight chain structure. So therefore, we have to give some alternative structure in addition to open chain structure, as these reactions are not possible with open chain structure, and therefore we give the ring structure also to glucose as we shown here. And this ring structure is always in what we call equilibrium with your open chain structure, that is both structure exist in glucose. So this is all about the last question. We'll continue this chapter in the next video. This is all for today. Thank you.